Physical properties of organic compounds. In this chapter, what we are going to discuss is the three physical properties, which are boiling point, melting point, and vapor pressure. So we already studied the definition for boiling point, melting point, and vapor pressure in grade 11, right? So you must make sure that you know the definitions of boiling point, melting point, and vapor pressure. So the question is, when you look at the organic compounds, how do you explain their boiling point or melting point or vapor pressure with each other? So that is how we are going to look at this chapter. It's an easy chapter. The only thing is you need to identify whether the given substance is an alcohol or aldehyde or ketone or ester or all these 9 homologous that you studied. So that is the main thing. Okay. So for that you need to understand this. If it is alkane, alkene, alkyne, you know, the type of intermolecular force in these compounds are London forces. Aldehyde, ketone, ester, and haloalkane, it is dipole-dipole forces. Alcohol and carboxylic acid, it has hydrogen bonding. So these ones you have to study. Out of these, hydrogen bonding is the strongest and London force is the weakest, that we studied already last year, right? So the question is going to be based on like if they are given two different homologous series, how do you explain their boiling point or melting point or vapor pressure? So when you look at boiling point and vapor pressure, how are they related? Boiling point and vapor pressure, they are inversely proportional. Wait, isn't it so? Boiling point and vapor pressure, they are inversely proportional. Means when the boiling point is high, the vapor pressure is low, or when the boiling point is low, vapor pressure is high. That we studied also last year, right? So let's have a look at an example and see how to deal with this. So if I'm giving you two substances, okay, one is hexane, right, and the second one is hexane 2 on. Imagine these two. So how do you explain the difference in the boiling point, that or vapor pressure or melting point? Okay, boiling point and vapor pressure, they are always in the exam, yeah, but melting point is also there, so you treat the same way as boiling point, melting point as boiling point. Okay, no, you don't need to differentiate there. Okay, right. So when you look at A and B, how do you explain their boiling point? Let's check. So we are going to write in point forms. Okay, in the first case you must first identify what type of intermolecular force they have. Okay, then you talk about their strength, which one has stronger intermolecular force. Then we are going to talk about the energy, right? If the if the intermolecular force is high, means stronger intermolecular force means you need more energy to overcome that intermolecular force, right? Weaker intermolecular force means you need less energy. So if energy is high, means boiling point is also high because you are heating at a higher temperature, right? So that's why boiling point is higher there. So the first point that we are going to write is, let's look at compound A and B. A is an alkane, B is a ketone. So we already identified now alkane has what type of force? London force. Ketone has what type of force? Dipole force. So you have to mention that as the first point. Okay, let me write. Alright, then after that you are going to talk about the strength of the intermolecular force. Okay, so between dipole and London forces, which one is stronger? Dipole. So either you can say dipole force is stronger than London force. If you don't want to say in that way, you can say the intermolecular force in compound B is stronger than A. Okay, alright. So then what is the third point? Okay, you don't need to write both points as the second one. Either you write this one or this one. Okay, it's your choice. And then you are going to talk about the energy. So when you look at energy, which one needs more energy? Surely it is dipole because it's stronger. Okay, so when you say, we can say more energy is needed to overcome intermolecular force in B than A. Do not use the word break. You will lose marks for that. Okay, so always use the word overcome. Now we can conclude what is the boiling point. So if you are talking about boiling point, we can say hence boiling point of B is more energy, means higher boiling point. B is higher than A. Or if it's melting point, same case, melting point of B is higher than A. But if it's vapor pressure of B is lower than A, because vapor pressure and boiling point, they are inversely proportional, isn't it? So based on your question, you can conclude. Okay, so this is how you need to answer. So this will give you how many marks? 4 marks. Okay, right. So please make sure that you understand. So if it is any other two compounds, the same way you are treating, you identify the intermolecular force, you talk about the strength, then you talk about the energy, and then you conclude your question. Okay, now when you look at two other substances, like if you have a question between alcohol and acid, how do you explain that? Okay, for example, if you get question like this, how do you explain that? Butane 1-ol and butanoic acid. So when you look at butane 1-ol, this is an alcohol, right? Then this one is carboxylic acid. We know carboxylic acid and alcohol, both of them have what bonding is, what type of force? Hydrogen bonding, right? So if they are hydrogen bonding, how do you explain? Okay, if both are hydrogen bonding, but still they have the same, different melting point and boiling point. So if you look at carboxylic acid, its functional group is C double bond OH, right? While for alcohol is C with an OH, isn't it so? Right. So how do you see the difference? Both of them can create hydrogen bonding. When you look at alcohol, how many hydrogen bonds it can create? It's only one, because it has hydrogen bonding is a force between hydrogen and oxygen, isn't it so? Last year we studied hydrogen and oxygen, hydrogen and nitrogen, hydrogen and fluorine, but we are only considering hydrogen and oxygen because it's for organic compounds. But when you look at carboxylic acid, okay, if it is difficult to understand, look at how many oxygens are there. That means 2 oxygens are there. That means they can create actually, or they can form actually 2 intermolecular forces, 2 hydrogen bondings they can create. There are 2 ways, 2 points where they can create hydrogen bonding. So that is the difference. Means carboxylic acid got 2 hydrogen bondings and alcohol has 1 hydrogen bonding. So surely which one is stronger? Is carboxylic acid. Okay, so we are going to talk about the same way like last example. We are first going to talk about the forces, and then you talk about the difference in the forces. Okay, so this is the way you need to explain. So when you look at my point 2, I wrote all the points. So when you look at point 2, you are going to state alcohol or compound A has one side. You must always use this word one side. Okay, one side for hydrogen bonding, while B has how many sides? 2 sides for hydrogen bonding. So this is important, you have to follow the same. Okay, so when I say one side, means one place where it can create hydrogen bonding, but acid got 2. Okay, right. So which makes the strength of intermolecular force in B is higher. B is our acid here, right? B is higher than A, right? Then we talk about what? Energy. More energy is needed to overcome the intermolecular force in B than A. Hence, boiling point of B is higher than A. So, if the question is based on vapor pressure, you conclude by saying, hence the vapor pressure of B is lower than A. So, this is how you answer between the different homologous series or same homologous series like this one. Okay. If you get questions like this, if you have A, B, C, D, propane, butane, pentane, hexane, maybe boiling point, melting point, vapor pressure, if they are giving you these informations, okay, usually there will be investigation type questions you can expect from here. So they can ask you for dependent variables. So in this chapter, dependent variable can be any one of these three. Dependent variable, dependent is the one that you are measuring, isn't it? So then independent variable, what are we changing? When you look at A, B, C, D, all of them are alkanes. So all of them are alkanes means their homologous series is the same. So that is the controlled variable, right? But when you look at their differences, propane means it has how many carbon atoms? 3 carbon atoms, right? Butane has 4. Pentane has 5. Hexane has 6. So when you look at it, what is changing here is the length of the chain or number of carbon atoms. So you can take independent variable as chain length or number of carbon atoms. Dependent variable, like I said, melting point, boiling point or vapor pressure, what is given in the question. Okay, if it's only boiling point, then your dependent variable is boiling point. And what is same here, the controlled variable is the homologous series. So if you get a question like this, how do you answer? Okay, that's what I'm going to explain about melting, boiling or vapor pressure. So first thing again that we are going to identify is the intermolecular force. All of them are alkanes, right? So what type of intermolecular force is it? It is London force. So that is what you are supposed to explain. And then from there, you need to explain the difference in the chain length, because you can see there is a structural change, right? So we are going to say from compound A to D, what happens to the chain length? The chain length increases. So that's how we are explaining their difference. Okay. Now, so the difference is the chain length. So how do you relate chain length with intermolecular force? So we can say as chain length, because as the number of chains increases or number of carbon atoms increases, or as the chain length increases, the strength of the intermolecular force also increases. Okay, so that is the idea. So if in that case, if you look at compound D, that is the one with longer chain, means compound D has a stronger intermolecular force, isn't it? So it needs more energy to overcome the intermolecular force. So we can say compound D has higher boiling point than other compounds or compound A, right? So the point here is when chain length increases, the strength of intermolecular force also increases. Okay, so this is the way that we are supposed to answer the question. So you talked about the intermolecular force. Since the intermolecular forces are same, you talk about the difference, and then how do you relate it with the strength? So as chain length increases, strength of intermolecular force increases. Then we talk about energy, and then we conclude. So this is the way you explain if you see that there is a difference in the chain length. Now if you get compounds like this A, B, C D, look at it: heptane, 2-methylhexane, 2,2-dimethylpentane, 2,2,3 trimethylbutane. In this case, how do you explain their boiling point or melting point or vapor pressure? So here also all of them are alkanes, right? So the difference is 1, 2, 3, 4, 5, 6, 7 heptane, right? Then the second one is Parent is hexane, so it's 1, 2, 3, 4, 5, 6. Carbon number 2 has a methyl branch. Okay, you need to include the number of hydrogens. I'm just showing you the difference. Okay, then compound C is pent. 1, 2, 3, 4, 5. 2, 2 dimethyl means we have 2 methyl groups here. Then for compound D, it's butane. 1, 2, 3, 4. Then 2, 2 and 3 also got a methyl branch. Okay, so when you look at this one, yes, of course, all of them are alkanes. That means they have London force, right? But what difference you can see? It's also difference in chain length, or we can say what? Number of branches. Because if you look at this one, this is a straight chain. Here you have 1, here you have 2 branches, here you have 3 branches. So when number of branches increases, how do you explain? So what you need to understand from here is, as the number of branches increases, the surface area gets smaller. So what happens to the intermolecular force? Intermolecular force decreases. You can connect it with the previous thing, because I said longer chain length means higher intermolecular force, right? This is the opposite. So we are talking in terms of what? Branches. So that's how you are explaining here. All of them have London forces, right? Then compound A to D, what is the difference? You need to explain the structural change. What happens there? As from compound A to D, the number of branches increases, or A is a straight chain, B to D has branches. So, or we can say from A to D, the number of branches increases. So if number of branches increases, what happens? The strength of intermolecular force decreases. So you need to include that point of smaller surface area, and then we can say this, then the strength of intermolecular force decreases. So now we can see this one has a stronger intermolecular force and this one has a weaker intermolecular force. That means D needs less energy to overcome intermolecular force, right? Or if you talk about A needs more energy to overcome the intermolecular force. So hence A has higher boiling point, melting point and boiling point and vapor pressure. B has lower boiling point and melting point, but D has higher vapor pressure, A has lower vapor pressure. So this is how you answer the question. So please make sure that you write in point forms. That is the accepted way that you need to follow. Okay, so this is how you can answer the questions. Okay.